I get to live and breathe what we do every day, and that is still a cool intro. I absolutely love it. Welcome in, everybody. My name is Jesse. I'm here with Exploring by the Seat of Your Pants. And if you're joining us for the first time, and so many of you are today, we are all about bringing conservation, adventure, and science into classrooms around the world. And you are catching us on a very exciting day for two big reasons. Number one, this is February, so this is our entire month solely dedicated to the most amazing women in science and exploration on planet Earth. We've got over 50 broadcasts this month, Egyptologists, paleontologists, Arctic explorers, botanists, and more. It's been a wild ride, and everything is on our YouTube channel. So if you want to check out like 50 broadcasts this month or 4,000 from all time, you can go there and do just that. And secondly, it's really exciting because we are back in our epic partnership series with the amazing folks at the Canadian Space Agency. We've done a program a month of them for a few months now. We've had astronaut David St. Jacques. We've had a few incredible engineers and scientists on talking about Mars, asteroid samples, and beyond. It's been a wild ride. I really encourage you to check out their website. There's so much on the go in space exploration right now. It is wild. It's like the coolest time to ever be interested in space in human history. So lucky you guys. I want to note before I turn you over to our amazing speaker today that we do have a Kahoot. So between our talk and our Q&A, if you want to play along with a little 4-question quiz, test your understanding, have some fun, you can pull up that game pin and do just that. Now, with that all said, and I will put that in the chat so everyone too, I'm going to turn you over to Carolyn Emmanuelle-Morisset, who is an amazing scientist getting to work on the Canadian Lunar Rover. She's gotten to work with moon rock samples, with asteroid samples. She gets to be one of the lead scientists on designing a rover going to another world. Like, that's what the moon is. We are exploring another world in this solar system, and we're doing it in the most dedicated and passionate way in like 50 years. It's crazy right now. So I'm so excited to turn you over to her to talk about the who, what, when, where, why of the Canadian Lunar Rover. Carolyn Emmanuelle, welcome to the broadcast with our 870 plus kids, and so nice to have you on the show.
Hey, hi everyone. It's so nice to be here today.
It's so nice to have you, and I know I did a way over the top intro, so I'm going to zip my lip and turn you over. We've got your presentation up. It looks amazing, and if you want to take us away, let's do this thing.
Perfect. So I'm so happy to be here today with all of you and talking to you about the first Canadian Lunar Rover, the what and the why. So I'm going to talk to you a little bit about the rover, then about the moon, the why we're going to the moon, and then I'm going to wrap up this presentation with showing you the type of questions that us scientists and engineers working on the mission had to ask ourselves at the beginning when we started the mission. We started the mission a few years ago, and the rover won't still be on the surface of the moon for another few years. So building a rover, building it correctly to make sure it's function on the moon, it's a story of many years. So first, I wanted to show you a little movie of what is it, a rover. So it's an engine that will be rolling on the surface of the moon. In our case, it'll be equipped with instruments that will feed back their data back on Earth. So it will be a little bit like the hands and the eyes of the scientists. We cannot bring on the surface of the moon so many scientists. So the rover will replace a little bit our hands and our eyes. And so that's what our rover is going to look like. What the image you're going to see today are the image of either the prototype of the rover or a drawing in a virtual environment of the rover. What's a prototype? So basically, the prototype is what we built on Earth to be able to test the rover, making sure it's functioning right in different environments. And then once we're really set, that we're sure that what we've planned is going to work, then we construct the actual rover that's going to go on the moon. So in the case of our Canadian Lunar Rover, the rover that's actually going to go on the moon is still not built, but we're working with the prototype that you see right now. That prototype and the actual rover will measure about 70 centimeter by 70 by 70. And it will be equipped with different cameras and sensors that will take measurement about the surface of the moon. One also important thing, if you look at the side of the rover, you see those little blue rectangles. Those blue rectangles, they're present on all sides of the rovers. They are our solar panel. So the rover is being powered, and there's a battery that gets charged by the solar power. And that gets cut into those little solar panel on the side of the rover. So we want to take our rover and go to the moon. The moon is our closest neighbor if we think about the neighbor in the solar system. And we see it not every night, but when we have the chance to look at the sky, when the moon is full, or when it's a quarter, only when there's a new moon we don't see it. But the other nights, if it's not cloudy, we'll see it. So we kind of become familiar with it. We have a feeling that we know it, but I hope that I'm going to still make you learn a few more things about the moon, because there's still a lot to learn about the moon. So here are a few fun facts about the moon. The moon is turning on itself in about 30 days, and it's turning around the Earth in about the same time. And that has the effect that we see only the same face, always the same face of the moon. That it took me myself a long time to really figure it out. And I figured it out while I took a globe and turned it around myself. So if you don't have a globe at home, you can take an orange or anything that is circle. And now I don't have a sphere, but even if I take something circular and you turn it slowly on itself, while you turn it around you at the same time, and you'll realize that that's why the moon is facing always the same face towards us. So do the exercise either with your parents or in class, and you'll understand the geometry and how things are turning, and that's why we always see the same face. Other interesting facts about the moon is that the size of the moon is about a fourth of the size of the Earth. However, the Earth, it's 80 times more. The mass of the Earth is 80 times more. So there's a huge difference between the difference in size and the difference in mass. And why is that? It means that the moon is way less dense than the Earth. And that, we think we explain it by how the moon formed. We have a theory that's called the giant impact theory. And that's the illustration on this slide. So we think that right after the formation of the Earth, when the core of the Earth had formed, the core of the Earth is really filled with a lot of iron. So it's very, very, very dense and very, very heavy. We think that right after that formation, there's an asteroid the size of Mars, okay, that really a huge mass hit the Earth. And that's what we see now in that image, is that asteroid hit the Earth, and all the debris that came from that collision started to turn around the Earth. The debris didn't hit the core of the Earth that had all the heavy mass of the Earth. And so these debris started to turn around the Earth and assemble and form the moon. And so since its formation, the moon, there's not much that happened to the moon. So now that's the face of the moon that we see from the Earth. That's the face of the moon that you can see when you look at the moon, and that it's a full moon. We can see really well that most of the moon is whitish, and I've put a picture on the screen of that whitish rock. So on the top right, the picture of that whitish crust is called an anorthosite. And what I've done as well is I brought you a piece of these type of rocks. We have them on Earth. This is an Earth rock, okay? I don't hold in my hands like that lunar rocks. I wouldn't do that. I would hold them with gloves and take them in really clean labs to not contaminate them. This is a piece of rock that I've collected myself. These type of rocks, the anorthosites, it's in Quebec, actually, in the world where we have the highest concentration of these types of rocks. So that's what most of the moon is made of. The far side of the moon is almost only made of this type of rocks, the anorthosite. Then the black spot on the moon that we do see with the naked eye. And now that you've seen this presentation, I hope that the next time there's a full moon, you go outside and you look at it, and then you'll see really well those dark spots. These are made of this type of rocks. And I've put a picture again. That's a picture of an actual lunar sample. It's called a basalt. I've put a terrestrial piece here on the screen. That's what I collected. I collected this in the volcanoes of Hawaii. So these types of rocks are what we call basalt. Like I said, they're volcanic rocks. They come from volcanoes. So the fact that they are on the moon, we know that at one point in its history, there were volcanoes on the moon. And that's basically since the formation of the moon cooled down, it created that crust of anorthosite, and then there was a few volcanoes of basaltic composition, like what we have in Hawaii. And so that's pretty much what happened. And then what's really interesting about the moon is that since not much else happened, it really, really kept all the recordings of all the impact of meteorite that happened on its surface. And I wanted to show you this incredible map that was done by NASA, measuring the difference between the lowest point of the moon, which are in deep blue, to the highest point of the moon, which are in red. And so the differences between the lowest point and the highest point are about 18 kilometers. So just by impact crater, it created that topography on the surface of the moon of still a difference of 18 kilometers. For a comparison, the Mount Everest on Earth is about 10 kilometers in elevation. And so there's a person that took the time to circle all the big craters on the moon. Now, this is a map. It's a bit, if you take an orange and you peel out the peel of the orange and you look at it as a rectangle, we often also look at map of the Earth that way, right? We unroll the surface of the Earth and we look at it as a rectangle. And that person circled about more than 5,000 craters with a diameter of more than 20 kilometers. So this is just to show you how many craters we've kept on recording on the moon. On Earth, we don't keep that recording. We have mountain chain that forms. We have ocean that formed as well that can erase that. We have air, we have an atmosphere, there's cloud, there's rain. All of this modify the surface of the Earth. As on the moon, none of this exists. And so these are just the craters that are above 20 kilometers in diameter, but there's multiples and multiples more craters that are smaller than that. Even the smallest meteorites makes it all the way to the surface and will create an impact. As on Earth, these ones would burn out in our air, in our atmosphere, and they would become shooting stars. So that's a big difference between the Earth and the moon. And what happened is that the surface, all these cratering and all these collision at the surface of the moon created a big mantle of dust, if you want, around the moon. So the surface is really covered with this dust, and we see it here on the picture. We can see at a few points there are larger rocks, but most of it is a very, very fine dust. I have more pictures just so that you can look at that surface, which is quite impressive. And the last picture showing like the print of the boots on that dust, a little bit like when we walk on the beach and we leave a mark, or foot would leave a mark on the sand. And so that dust is very, very fine, and it can be very harsh. The astronauts of the Apollo missions, the only men that have been on the moon, that was about 50 years ago, complained that even though their combination was really made to be tight for dust, it was still making its way in, and it was itching them because that dust, because it all come from broken rock, can be really, really itchy. So we do want to go, when we go with our rover, we do want to go explore the craters that have been formed by all sorts of meteorites impact, because we think that there might be a chance that there's water ice on the surface of the moon. And why do we want to find water ice? And first, what is water ice? Why do we say water ice? Water ice is simply water that's frozen. So today, for those who are in Canada, we're really in the heart of the winter, right? There's lots of snow and water ice outside. We talk about water ice on the moon because there are some places that are so cold that we could have carbon dioxide ice. But now what we want to focus on is really the water one. Why? Because the astronauts that would go and explore the moon, they do need to drink water. They need water to wash themselves, and they need water to prepare their food. So if we can find water for them on the moon, it means that they wouldn't need to bring all the water they need for the whole trip with them. So I'd like to compare that a little bit, that if you're planning your camping trip for a week or two, if there's water at the campground, you don't bring with you all the water that you need for that week or two of camping. So it would be the same principle. It would make traveling to the moon easier and the luggage to bring with you more simple if we don't need to plan all the water that the astronaut would need. Eventually, what we're hoping as well is that we'll be able to grow our own food for our own need on the moon, and for that we would need water to water the crops that might be on the surface of the moon. So that could help for that as well. Then one more thing is that water is made out of oxygen and hydrogen. And if we found water, we can separate these two. We can separate the oxygen from the hydrogen. And again, the astronaut, they breathe oxygen. On Earth, there's oxygen as part of the air, and that's what we breathe. That's what our body needs to be alive. So if we do have a source of oxygen on the surface of the moon, again, it will make traveling there a bit easier. And then both hydrogen and oxygen can be used as rocket propellant. So what we're hoping is that one day we'll be able to go and refuel at the surface of the moon to go and explore further. So that would mean that you bring your rocket and then you refuel and you go explore further in the solar system. A little bit like if I want to travel from Montreal to Toronto and I stop along the way to put gas in our car. It allows us to go further in the same trip. So now that I've told you a little bit about our rover and the moon and why we want to go to the moon, I want to take you through a few questions that we asked ourselves when we started the mission. So we're about 60 engineers and scientists working on the missions. And these are the type of questions that we asked ourselves. So a first question is, okay, we want to go to the moon. We want to go find water ice. Where is it are we going to go? Are we going to go to one of the poles, or are we going to go to the equator? And to help ourselves, we look at different data that were available. Part of it was that map, which is a map of hydrogen concentration on the surface of the moon. So on the map, in the center of it, you see one of the pole, and around the circle is all the equator. And the colors are representative of the different concentration of hydrogen. So the low concentration are in the purples, and the higher concentration are in the yellow and white. So looking at this, you remember I've said there's hydrogen in water. We look at the concentration, and there's higher concentration of hydrogen near the pole. So we decided, okay, we'll go to the pole, and in particular to the South Pole, because in the scientific community, there's an understanding that we should go explore one of the poles first, make sure that we explore correctly, that we don't pollute the moon, that we leave the moon intact after our exploration before we go and explore another pole. So we're going to go to the South Pole of the moon. A second decision we have to make, and then don't worry, I'll play that movie again because it's just too cool to watch. But we were wondering, when are we going to go on the moon? Which season? So we have the January, which represent the lunar South Pole summer. So we are in the northern hemisphere. The summer for us is in July, and now we're in the heart of the winter. Just looking outside, we know February, we're in the heart of the winter. But on the southern hemisphere of Earth, or on the south lunar pole, January is actually the summer, and the opposite for July. We're actually at the lunar South Pole in the middle of the winter. So I'll play the video again so that you can see the difference, that it's really the same spot on the moon. But do you see the difference in illumination at the South Pole when you're looking at the summer, which is in January, versus the winter, which is in July? The difference is quite incredible. And if you remember at the beginning, I've mentioned that our rover is solar powered. So we've decided to go during the summer at the South Pole so that we could more easily power our rover with the solar energy. So now we've decided we're going to go to the South Pole. We're going to go during the South Pole summer. But when we're at the surface, what are we going to explore? Are we going to explore only sunlit area, or are we going to go in the shadow? So I'll play the different answer with movies. So here you have a movie of a rover that is being in the sunlit zone. It's been exploring the moon for about 10 days, and we've gone across maybe 10 kilometers, and we stayed in the sunlit area. On the moon, like I've mentioned, there's no air, there's no atmosphere. So the temperature is really dependent on whether I'm in the sunlit zone or I'm in a shadow zone. So in the sunlit zone, it's an extremely warm temperature. It can reach 120 degrees Celsius. So we think in Canada, we know extremes of temperature, right? Because we know that in the summer, it can reach 30 degrees Celsius. In the winter, it can reach minus 20 in the south of Canada, or 30. And even in the north of Canada, it can go maybe to minus 50 in extreme environments. But on the moon, the sunlit area can reach 120 degrees Celsius. Water is boiling. So while we explore and stayed only in the sunlit zone, we didn't found any water ice because water evaporates so fast. So now we've decided to also go and explore shadowed area. So now you have a rover that's going to go in a shadowed area. In the shadowed zone, the temperature can reach minus 240 degrees Celsius. So that is cold. So we're hoping that we can find water ice in this zone. We don't want to stay long though, because we do need to charge a rover with battery. So we want to go to the shadow zone, but stay very limited time, because if we're not out of there fast enough, the rover is going to die. If we don't charge it in time, there's nothing we can do. The rover won't be able to charge its battery, and the rover is going to die. We'll need to abandon our mission. So the last decision I want to share with you is that we were wondering how we're going to manage the different terrain on the moon. And for that, I'm showing to you that between the two blue arrows, we want to go and explore that crater. That crater is really nice. It has a nice sunlit area. It has a nice area which is in the shadow. And we need to understand how we're going to go down in that crater. So there's two paths to go in that crater. And you see the little rover where we're at. We're just at the bottom of that bottom blue arrow. We have a way in that's really direct, that we would make it go fast to that crater, but it has a really, really steep slope to go down that crater. But we would be there faster, and we would have more time to explore the crater. The other path, we have to go around the crater. Then we will go more slowly in the crater. We'll it would take us more time to go. Then it would take more time to go down because the slope is more gentle. So we would have less time to investigate that crater. So let's go see what we've decided to do. So that's a video of the steep slope. So we entering the crater, everything goes well. We go down, but oh my God, oh gosh. The rover went on a way too steep slope and one of its wheel broke. And there's nothing we can do. If the rover is broke, there's no human going on the flight with us. So if the rover breaks while we're there, that's it. The mission, we can't finish it. We need to abandon everything and we won't fulfill the full mission. There's nothing we can do. So if we take the path that has a more gentle slope, we'll go more slowly, but we made it to the bottom of the crater. And now our rover's starting to explore the crater and found interesting rocks to look at. And now it's going to go to a place where we do find water ice, and we've explored a shadowed area. We found water ice. The mission is accomplished. So basically, we're going to move really slowly. We're going to be really, really careful. Every minute is going to be planned ahead of time to make sure that we've planned every move of the rover. And then while we're on the surface, the rover is going to take a picture, going to return the picture to the Earth. Then a command is going to be ordered for the rover. And so it will go very slowly to ensure that we avoid obstacles and we don't go on too a harsh slope, because really that could mean that we have to abandon our mission too early. So really, I hope that you've learned a bit about the rover and about the moon, and you're as exciting as I am about our mission. We're going to go there in a few years, and we will keep everyone updated as we keep planning for the mission and developing our rover. And during the operation, we're going to share the data with everyone as soon as we can, so that you're all excited about the findings we're going to have from the surface of the moon.
Awesome. Carol and Emmanuelle, that was fantastic. Thank you so much. I've got the moon with me, so we want to have it orbit me, and we can see the one side of it, where we can absolutely do that during the broadcast. We're going to start with our Kahoot. So 4 quick questions to see who is paying attention to some of the things Carol and Emmanuelle was talking about. And if you want to come out of screen share so you can see us again, have a bit of a conversation, please do. We've got so many kids today from all across North America and beyond. So really, really exciting to dive in with questions in a minute. I want to note, if you're new to Kahoot, the faster you answer, the more points you get. And what you win is Carol and Emmanuelle and I's everlasting respect. So good luck with that. No pressure at all. There's already a bevy of you in, which is awesome. So we are going to dive in with this in just a second and get underway. And then John T. Tuck, our grade 6 crew, you guys are going to be our first class for questions when we do go live into Q&A. I want to stress, please do, classes, write down additional questions. We'd love to take more after the broadcast is done. I'm going to put my moon down for a second, and we are going to get underway with our Kahoot. Carol and Emmanuelle, if you want to help us with some hints for any of these questions, please do guide us on the right path as we dive in with 20 seconds for each question. Here we go. All right. Dun, 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 dun. 3, 2, 1. First question. How many people have set foot on the moon ever? Is it no one? Is it 12 people? Is it 110? Or is it over 1,000 people? We're just going to the moon all the time.
So there were 6 missions with humans on the moon. And you want me to help a lot, or you want me to help just a bit?
Help however much you want. We got 1 second
so
left.
6 missions.
Yeah. And two people on each one. So 12 is our correct answer. Let's see what that does to our leaderboard. I think Kahoot's been having some trouble with some folks today. So don't worry if your answer didn't come in. You can just yell out the answers in class. I know there's a bevy of you in, so the answer should be coming in. But as I said, something should go wrong in every video broadcast. When was the last time we landed people on the moon? Of those 12 people, was the last vision 2022?
You remember during that talk, I said it was about 50 years ago that there was the last man on the moon. So
very nice.
Do a quick math. It should help you.
1972 is our correct answer. I don't know why none of these are coming through. That's the first time that's happened in a Kahoot in ages. So if you said 1972, you are correct for the 90 of you that are in on this Kahoot that is refusing to accept queries. But let's go to question 3. Now we're getting specifically to the Lunar Rover. So who is really paying attention to the nuts and bolts of the presentation? The Lunar Rover is looking for, what's it looking for? Is it looking for aliens, other rovers to like hang out and have fun, water ice, or regolith, which sounds very scientific?
That one I don't help because I think I've mentioned it a lot during the presentation.
Yeah.
So
we want you guys to just know this. Let's see what we get. Oh, now the answers are coming through. Now they've deigned to work. Excellent. Yeah, water ice. A few of you thought alien. That would be so cool. If we found an alien, that would be a big surprise, and the Canadian Space Agency would be so famous so fast if the Canadian Lunar Rover found an alien. But no, water ice is our correct answer. All right, let's go to our final question for all the marbles. And then John T. Tuck, we're coming to you. On the moon, the rover will be able to withstand temperatures of what? -10, -25, -40, or over -200, which is way colder than the Earth ever gets.
Well, that also I've mentioned, right? So it's when I talked about the shadow, how cold it can be in those shadows. It has nothing to do with the temperature we know on the Earth.
And our audience knew that. Most of you got that right. Yes, -240, you said, which makes like the far north in Nunavut look like a tropical paradise with palm trees comparatively. All right, Bronzy Muse third, Smart Piranha second, and first, for all the marbles, let's see, is Goose Agile. Well, way to go, folks. Thank you so much for playing along. And as I said, we're going to dive in with a nice Q&A. Please do write down extra questions you have afterwards. But John T. Tuck, take us away, grade sixes. Hi, guys. Hi.
Hello.
Yeah.
How many rovers have been on the moon?
How many rovers have been on the moon? Great question.
Oh, that's a great question. And sincerely, I haven't made the count. There's been rovers from NASA that has helped the astronaut. There's been a few rovers from Russia that have gone and explored the territory without astronauts on them. Now there's been a rover from China. There's still an active one right now. And there's been a rover, I think a successful rover from India. And Canada's going to go next. So I haven't made the count, but it starts to be close to 10 or a bit more to 10.
It's getting up there. It's pretty wild. And as you said, India and China have recently launched them. Like, it's this golden age of space exploration. More countries are getting involved and sending things to the moon for the first time ever. So it's a really, really exciting time. And I love that as the first question. We stumped the scientists to start. Yes, I love when this happens. Mrs. Parrish's class, we're going to head to you next. And then our grade 6A in Kitchener, you're after that. Hello, Mrs. Parrish. Hi.
Some of our students have gone to recess, but we do have some that are wanting to ask burning questions.
Amazing.
I was wondering if we're going to mine like in the moon.
Ooh, are we mining the moon? What do we think?
So I guess, some people are looking towards if there are, metals like on Earth to mine on the moon. Right now, we're taking water ice as our resources. It's very, very different than on Earth, because water on Earth is everywhere, and we just take it a little bit for granted because it comes out of our tap water. So I think the first resource that we're trying to find on the moon is water ice, because as explained, it's going to help so much exploration if we can find it over there. So that's a very nice question, because it makes what we consider mining and resource on Earth, they're different on the moon, because we have it's just different because the water doesn't flow like on Earth.
Yep. Well, and I want to stress for our students, because it sounds so, in theory, so cool. Oh, we mine, we get minerals from the moon. Well, we've got to get them back. We've got to get the things there to get them. Then we've got to get them back, which is insanely crazy expensive. It is so expensive to take a pound of something into space, much less to the moon. And to think about bringing millions and millions of pounds of stuff back is actually quite beyond our technological capacity right now.
We're not there. That's a very good point. So what we're trying to find right now is resource on the moon that we could use there. And not necessarily, that's the first step. The first step is to find resource on the moon that we could use there to implement, easier traveling there. That's a very good point, Jesse. Thank you.
Yeah, you're welcome. All right, grade 6A in Kitchener. If you want to flick on your mic, I'll come to you that way. Madam Stephanie, you guys are going to be next, but you did share this in the chat as well. They want to know, how do we control the rover? So it's driving around. How is that happening? Is it someone with like a PlayStation controller back at home or what?
So it's a very good question as well, right? How we're going to control that rover. So basically, while the rover is at the surface of the moon, it will take a picture of where it is. It will send that picture back to Earth, and it has different cameras. It's equipped with two cameras at the front that are higher up that would give a wider view around the rover. It's equipped with a small camera down at the front. That one is called the hazard camera, to see if it would take a closer look right in the front of the wheels of the rover to make sure like we didn't miss a big rock. And then there's cameras on the side as well to make sure we have a view from almost all around the rover. So it will send back these images to Earth. Then there'll be an operator that will be looking at those images. And when they see the ground is clear in front of the rover, it would send a command to the rover and say, okay, move 1 meter, turn 90 degree, right, turn 90 degree left, and then move 1 meter. It will send little command to the rover. The rover will execute the command, and then it will take a series of pictures again and send it back to Earth so that the cycle is starting again. And so the whole point of that cycle is to make sure that we make the right command, we send the right command, and that nothing happened and we're not missing anything in the meantime.
We talked about this with our Mars rover program last month with the Canadian Space Agency, and it's so challenging because you'd think, oh, we drive around, we're going everywhere, but you've got many millions of dollars invested in this, and it's there for science. And if you make a mistake, there's no one there to go pick it up and turn it upright. So It's a big challenge. Rovers tend to be very, very slow moving, but they make just incredible discoveries, and that's one of the key essences to the whole story. So I'm so glad we got that question, Kitchener. Thanks, guys. All right. I'm going to try. We've got 5 more live classes. There are so many of you, and there's a whole bunch of questions on YouTube. So we'll try and do like as many as we can, one from every live class for sure. Madam Stephanie, come on in. Hey, folks. Unmute, though. Hi. There you are. Wants to work. Perfect.
Hi.
Hi.
Did you send rovers to different planets or just the moon?
Great question.
There are rovers that have been to Mars, and there are rovers that have been to the moon at the moment. Our first Canadian rover will go to the moon. That's our first step. And we already have plans for another rover to go to the moon again. So right now, Canada is building rovers to go to the moon as we speak today.
Woohoo. Awesome. It's as I said, I keep stressing this. I know it sounds ridiculous. It's like the best time ever. You kids are going to be the generation that goes to the moon, that goes to Mars, that is involved in this grand exploration of our solar system. Like everything is really, really exciting right now. So I'm so happy you guys get to grow up in this time. It's way better than it was when I was a kid. It rocks right now. Meadow Montessori, we're going to head to you guys live. Come on in. Take us away. Hey, guys.
Ada's question is good.
Perfect.
Can you hear us?
Yeah, perfect.
Yes.
Okay, great. Ada, do you have that question? Want me to read it for you? You're going to read it. Go for it. Okay. Ada wants to know, why do humans want to live there on the moon?
Ooh.
Hey, that's a good question. I think that comes back, like, I don't think I have the single answer to that. My understanding is that we've always wanted to explore territory, and now we want to explore further. I think it's part of human nature to try to understand the environment that brought us here, and where can we go further. So I think it's a strong desire to go and explore further. That's, I think, why humanity wants to go. As a scientist, I want to go because there's so many questions still about the moon, that we need to understand. And as I've explained, we have theories about how it formed, but we need to collect more samples to make sure our theory hold the road, and how the moon evolved. I think there's so many questions to answer. How much water is there? And is there enough for us be able to live on that water? There's so many questions. So my whole motivation is about finding answers to questions that I have when I look at the moon.
Yeah. What a great answer. And I mean, to the exploration front, I mean, think about Antarctica here on Earth. We went and there were these 1 kilometer sheets of ice and it was so inhospitable and the ship's masts were freezing and we so wanted to go that now we have bases and thousands of people that live in Antarctica. Like no obstacle stops us when we want to explore and go to a place. And it's just really exciting that next frontier is other worlds in our solar system and the moon and Mars and beyond. So very cool question. Thanks, guys. All right, I'm going to take a quick YouTube one, and then Emmanuelle-Morisset and then Mr. Hancock will wrap up with you. I know we have way more questions than we could take, so please do email them to us at exploringbytheseatofyourpants. We'll get you some answers after the show. Mr. Barron's class wanted to know, you mentioned rocks and dust that got uncomfortable to the astronauts on the moon. How did it get in their suits to begin with? Like how it should be airtight. What's going on?
It should be, right? It should be. And it was because it contained all the oxygen that they needed to breathe. It was within their suits. But that dust is so fine and it's so sharp that it made it through any joints. That's what the astronauts were complaining about. So I think the teams that are developing the new suits are trying to make them even tighter to keep the dust out. So that dust is tricky, and it was really making them really itchy. And you can't scratch easily. You can't scratch yourself easily when you're in those suits.
There's a great book I read a few months ago, Our Moon by Rebecca Boyle, usually for our older audience today, but just talked about that dust. It doesn't get worn down by wind or rain like it does on Earth. So it's really sharp. It's like volcanic glass almost, and it's not a pleasant thing to be on you. It's itchy and painful and awkward. I also want to highlight, I put this in the YouTube and the StreamYard chat. You talked about how the moon was formed early in the broadcast. That's one of the coolest things ever, that like a giant chunk was blown off the Earth and reformed our moon. There's an amazing visualization video that I've sent to our classes, so you can check that out as well. All right, 2 more questions before we wrap up. Time flies and you're having fun. Emmanuelle-Morisset, let's head to Winnipeg. Welcome in. Hi, guys. How you doing?
Hello.
Come on in.
How much does a mission usually cost to go to the moon, and who pays for it?
Yes.
That's a good question. So there's all sorts of budgets depending on the size of the mission, depending if humans are going or not. So our Canadian Lunar Rover cost about 43 million. And it's all your parents, it's everyone in Canada. It comes through the tax that are being collected, goes towards a small part of it. The 43 million went to building and planning that rover to the moon. So all these, all that cost goes to the company that's building it, Canadian and the science team that is across Canada to different universities to help them work on that and build the prototype. And then build the actual rover, and then making sure all the instrument that's going to collect the science and the data are doing the right things. And then all the data collected is going to come back to Earth, and it's going to be open for everyone to have access to those data. So it's going to help improve our knowledge and our science of the moon.
Yep. I will say for our students, I mean, because I love when we get this question, the amount of budget that Canada and the US and the world spends on space exploration is like 0.4 of 1 penny on the dollar. Like it's almost nothing. And it pays for all the exploration of the moon, Mars, the solar system beyond, some of the greatest discoveries in the history of mankind. So it's really, really exciting and way beyond worth it. I think we should spend more. And I truly do believe that in my heart of hearts. So great question, guys. Before we go to Mr. Hancock, I got a really quick, easy one from Mr. Edwards, 4-5 class. How heavy are the rovers? How big?
So the Canadian rovers that now, the small one that you've seen, I shouldn't say the small one, the cool one that you've seen, because it's going to be able to do all that it has to do with the 70 by 70 by 70 centimeter, is going to weigh about 35 kilogram. So it's going to be a lightweight rover that will collect incredible data. And I just want to add that, the data that's going to be collected is going to be available to work on for decades. So you guys are going to be able to work on these data when you grow up.
Yes. It's very exciting. I mean, you've highlighted that a lot. I know that might be something that our students aren't familiar with as an idea, but the fact that we open it up to everyone to use this data is a really amazing thing about space exploration. 35 kilos is about the weight of like a big Labrador retriever. Like my dog growing up was 35 kilos. So there you are.
There we are.
Mr. Hancock, we're going to wrap up with you in Georgetown before we bring in all our classes for a big thank you and farewell. Come on in with fun final question. Hello.
Thanks, Jesse. Caroline, we had lots of questions. If there is the water ice, thinking about this sharp dust, would it be drinkable?
Ooh.
So that's a good question. There are challenges right now that are advertised to ensure, if we do found that water ice, how we're going to treat it to make sure it's drinkable. So that's a question that scientists are actually, and engineers are scratching their heads right now around. So not only do we need to find it, but once we found it, what do we need to do with it so that it becomes drinkable water and it can be used to also wash, that the astronaut could use them to wash themselves and also to cook and prepare their food. So answer to come in the following years, I guess, once research will have found a solution.
Carolyn and Emmanuelle, this has been so much fun. I know that we could talk all day about the moon rovers, and thank you. Some of you teachers are already emailing me some extra questions, so we're going to pass those along to the Space Agency team. Before we bring in all our classes for a big thank you and farewell, is there any final message you want to leave us with about the rover, about Canada and space, anything before we say goodbye?
Well, I think the one thing I'd like people is to stay curious. The reason I'm here, the reason why all the team of engineering and scientists are working on the rover is because we're all curious people, not because we know all the answer, but really because we're curious and we like finding answers. And it's not like we have all the answer from the get-go, right? Sometimes it took me years to find an answer, and I never found an answer alone. So don't get discouraged. Ask yourself question, found the answer, and in team, and never be intimidated to ask your questions, because probably, it's in a team environment that you'll find the answer. And when it's harder to find the answer, sometimes it's when it's the funner, because when you do find it, you're really, really happy about it. So stay curious, and that's what I guess that's my great message here.
No better message than that. Carolyn, Emmanuelle, the whole Space Agency team, and all our classes, thank you all so much for joining today for a really exciting broadcast. We're going to email you all sorts of information about the rover and beyond right after this broadcast. And to wrap up every show, we're going to bring you all in to say a big thank you and farewell. Space Agency folks, stick around for a minute when we're done. But John T. Tuck, Mrs. Parrish, Madam Stephanie, Madam Montessori, Mr. Hancock, and thank you so much, everybody. Have a wonderful day. Bye for now. All right, we are done live, everyone.